And this video will show you how to apply Ohm's law and the power formula to some actual circuits. So we'll start out by taking a look at a review of what Ohm's law is. Ohm's law, V is equal to IR, voltage is equal to current times resistance. And we normally use the base units in the SI system, volts, amps, and ohms. However, if you have resistance in kilo ohms, which is pretty common, then you could just go ahead and get your answer directly in terms of current of milliamps, and you don't have to worry about the metric prefixes. That will work out if you have those two combinations, and we'll see that in a few minutes. There are also variations of Ohm's law. You can understand the algebra of how you get these, or you can just memorize these variations. I is V over R, or R is V over I. Power formula, power is equal to current times voltage, and the units for power are watts. And again, we have variations of the power formula. V is equal to P over I, or I is equal to P over V. And we also have combinations of both Ohm's law and the power formula. I think the most common are P is equal to I squared R, or P is equal to V squared R. So let's go ahead and take a look at some examples of how this is used. As I put up a problem, I encourage you to simply pause the video here and try to work out the answer yourself, and then hit play again to see if you did it correctly. So here is our first problem. We are given current and resistance. We want to find voltage. So go ahead and pause if you want to try this on your own. And if you want to see the answer, we first of all apply Ohm's law. V is equal to IR. So I is 1.5, R is 20. We do a multiplication, we get V is 30 volts. So our answer is 30 volts. Now here's another one where we're solving for I instead of V. So if you know how to do that, I'll pause the video now. And if you want to see, this is a variation of Ohm's law. I is equal to V over R. So I is equal to voltage of 15 divided by the resistance of 45, gives you 1/3 of an amp, or 0.333 amps. Decimal 333 amps would be your answer. Let's look at another one. This one we're trying to find the resistance. This is another variation of Ohm's law. R is equal to V over I. So 100 divided by 2, we get an answer of 50 ohms. Now here we're going to try to find power, so we're going to use the power formula. So power is current times voltage. That would be 2.5 times 40. That gives us an answer of 90, and the units would be watts. 90 watts. That's the power dissipation. When you apply current to a resistor, that changes the electrical energy into thermal energy, so the resistor gets warm, and the amount of warmth it get would be equal to 90 watts. Here is another power problem. This time we're finding current. So current is power divided by voltage. 5 watts divided by 25 volts gives us 0.2 of an amp. This time we're trying to find voltage given power and current. Another variation of the power formula, V is equal to P divided by I. So 6 divided by 2 gives us 3 volts. Another example, trying to find power. This time we know I and R. This would be a combination of both Ohm's law and the power formula. P is equal to I squared R. So we have 2 squared times 5. 2 squared is 4 times 5 is 20 watts. 20 watts. Here's another one to find power. This time we're given voltage and resistance. So P is equal to V squared over R. Again, a combination of the power formula and Ohm's law. V is 6. We're going to square that and divide by the resistance of 10. So we'll get 3.6 watts. And here we have another Ohm's law. We have current and resistance. Try to find voltage, but this time we're using metric prefixes. So we do V is equal to IR, and because we have milliamps and kilo ohms, we can get directly our answer of 30 volts. 2 milliamps times 15 kilo ohms is 30 volts. Another one using our metric prefixes. So if you kind of figure it out using the metric prefixes, the current is 2, and the milli means 10 to the minus 3. Resistance is 10. The kilo, the K, means 10 to the third. If you do that arithmetic, you still get 20 volts. So that kind of proves what we saw a moment ago. Okay, and a moment ago what we were doing is just using the milliamps and the kilo ohms. So we would have done 2 times 10 and gotten 20, the same answer. We could do that again here. However, see, the resistance is not given in kilo ohms. So we run into a little bit of problem. So we have to go back and use the metric prefix. Milli is 10 to the minus 3, so it's 5 times 10 to the minus 3, multiplied by the resistance of 500 ohms, and we will get 2500 milli, which is 2.5 volts. 2500 times 10 to the minus 3 is the same as 2.5 volts. And here we have a current and a resistance, again, kind of mixed units. We don't have a milliamp there, we have just amps and kilo ohms. So we're going to use a scientific notation. 0.05 amps times 1 times 10 to the third. Kilo is 10 to the third. And what we get is 50 volts. Here's another one. This time we're trying to find resistance, and we're given a current in milliamps. So using scientific notation, we get resistance 15 times 10 to the third. Or we can remember that if we use milliamps, we're going to get an answer of kilo ohms. 15 divided by 1 will give us an answer of 15. And again, the units will be in kilo ohms. So 15 times 10 to the third ohms and 15 kilo ohms are the same answer. Here's another one. This time we're given kilo ohms and a voltage. We want to find the current. So Ohm's law, I is equal to V over R. 24 divided by 12 times 10 to the third. And that gives us 2 times 10 to the minus third amps. And that's the same as 2 milliamps. Okay, and if you want, you can just assume that if you're given kilo ohms, you're going to get an answer of milliamps. So there's your 2 milliamps. Either way, you can solve that. And here's another one. We're trying to find power in this case. So power is equal to current times voltage. We have 2 milli, 2 times 10 to the minus 3 times 15. That gives us 30 milli, which is 30 milliwatts. 30 milliwatts. So that should give you some idea of how to utilize Ohm's law. Of course, we chose numbers that were convenient and came as nice and even. You may have numbers that are more difficult. You may have to use a calculator. But if you know how to use the formula, that should be pretty trivial at this point. So thank you for watching, and look out for more videos on Mark's Tech Talk.